Right now, there's an electrical panel hiding inside roughly 25 million American homes that has never been recalled. Independent testing shows that up to 60% of these breakers fail to trip when they are supposed to. A New Jersey court ruled that the manufacturer committed fraud to pass safety testing for at least 15 years. Peer-reviewed research links these panels to an estimated 2,800 house fires, 13 deaths, and $40 million in property damage every single year. The government found out about it in 1980. They investigated it for 3 years, and then they closed the case. Not because the panels were safe, because they could not afford to prove they were dangerous. Today we are pulling this panel out of the wall and showing you exactly what went wrong, who covered it up, and how to find out if it is in your house right now. Let us talk about what a circuit breaker actually does, because most people never think about it. A circuit breaker has one job. When a wire in your wall carries too much electricity, the breaker trips. It cuts the power before the wire overheats, before the insulation melts, and before your wall catches fire. Inside, it is simple physics. A bimetallic strip bends when it gets hot from excess current. That bending unlatches a mechanism and opens the contacts. For a dead short, an electromagnetic coil trips the latch instantly. It is the last line of defense between a wiring fault and your family sleeping upstairs. You never think about your breaker panel. It sits in the basement or the garage, and you only notice it when something trips. But when it works, it saves your life without you ever knowing. Every modern panel from brands like Square D, Siemens, and General Electric does this job reliably. The failure rate on a properly manufactured breaker is roughly 0.01%. Now imagine a breaker where that failure rate is not 0.01%, but 25, 40, even 60%. Imagine that breaker is not in some industrial warehouse. It is in the basement of your 1972 split level. It is behind the drywall of your 1965 ranch. It is protecting the circuit that runs your dryer, your oven, and your air conditioner. That is not a hypothetical. That is a product called the Stab-Lok, made by a company called Federal Pacific Electric. And for roughly 30 years, it was one of the most popular residential breaker panels in America. But understanding how it ended up in millions of homes requires going back to the beginning. Federal Pacific Electric started in 1901 in Chicago as a company that made illuminated store signs. Over the next 50 years, through mergers, acquisitions, and wartime government contracts during World War II, it evolved into a circuit breaker manufacturer headquartered in Newark, New Jersey. By the late 1940s, everything except the circuit breaker business had been spun off or sold. In 1950, FPE registered the Stab-Lok trademark and started selling breaker panels to the residential market. The timing could not have been better. America was in the middle of the biggest housing boom in its history. The GI Bill was sending millions of veterans into new suburbs. Levittown had proved the model. Builders were putting up hundreds of homes at a time, and they needed electrical panels that were cheap, compact, and fast to install. FPE delivered on all three. The Stab-Lok's design was simple. No screw terminals, no complex wiring. You stabbed the breaker into the bus bar, and it was done. Electricians loved it because installation was fast and simple. Contractors loved the price because FPE consistently undercut the competition. By 1958, FPE operated 14 factories and 70 sales offices. By 1964, they had 22 plants in the United States and 5 overseas. During the 1960s and 70s, Stab-Lok panels went into roughly 10% of all new and remodeled American homes. That is not a niche product. That is a dominant market force. Florida subdivisions, California tract homes, Northeast suburbs, several hundred million individual breakers were manufactured and installed across the country. Now the corporate ownership tells its own story. FPE's parent company was a mining conglomerate called United States Smelting, Refining, and Mining, which renamed itself UV Industries in 1972. In 1979, UV Industries sold FPE to Reliance Electric for $345 million. And just months later, Exxon Corporation, one of the largest companies on Earth, bought Reliance Electric for $1.2 billion. So the biggest oil company in the world now unknowingly owned what would become the most dangerous consumer electrical product in American history. Exxon thought it was buying a motor company. It inherited a scandal that had been festering for decades. Nobody at Exxon knew, because the danger was not an accident of engineering. It was deliberately hidden inside the design. The Stab-Lok breaker uses a unique connection method. Instead of spring-loaded clips or screw terminals, the breaker is physically stabbed into cutout openings on the panel's bus bar. Copper blades mating with aluminum bus bars. Two different metals, with two different rates of thermal expansion. Over years of heating and cooling, connections loosen, resistance increases, and arcing begins. Field inspections found that 1 in 4 panels showed evidence of internal overheating, and in the worst cases, fire had ignited inside the panel itself. But the bus bar problem was not even the main defect. The main defect was catastrophically simple. The breakers jam and refuse to trip. In a 2-pole breaker, the kind that protects your 240-volt dryer or oven circuit, a linkage mechanism is supposed to connect both poles so they trip together. In the Stab-Lok design, that linkage creates friction. When an overcurrent occurs and the trip mechanism tries to release, the friction causes it to seize. The breaker is supposed to save your house. Instead, it locks itself in the on position and lets the wire burn. X-ray inspections confirmed it. The internal trip lever releases, but the electrical contacts stay mechanically stuck closed. Engineers called it the functional equivalent of putting a penny behind a fuse. And once a breaker jams, it is permanently disabled. It will never work again. But it gets worse. There is a second defect called the false off problem. When the internal mechanism jams, you can physically move the toggle handle to the off position, but the contacts stay closed. The circuit stays live. An electrician flips the breaker to off, reaches into the panel, and gets hit with 240 volts because the handle lied to him. One licensed electrician reported being shocked by a 2-pole breaker he had physically removed from the panel. It was being backfed through the bus bar and still conducting electricity despite being disconnected. So how did a product this defective pass safety testing? It did not. It cheated. Every electrical product sold in America is supposed to carry the UL mark from Underwriters Laboratories. That mark means the product was tested and meets safety standards. But here is how UL testing actually worked in those days. The testing was performed by FPE's own employees at FPE's own facility, with a UL inspector merely watching. FPE exploited that system. According to evidence presented in the New Jersey class action lawsuit, FPE engineers used hidden remote control devices to secretly force breakers to trip during UL surveillance tests when the internal mechanisms were failing on their own. They stamped the UL label on products they knew had never passed. The fraud was discovered after Reliance Electric bought FPE in the spring of 1979. Reliance engineers ran their own tests and found the breakers failing at relatively low overcurrent conditions. By May of 1980, Reliance executives realized this was not a manufacturing defect. It was deliberate deception spanning more than a decade. In June of that same year, Reliance sued FPE's former parent company for $450 million. They halted all Stab-Lok shipments. They suspended FPE's president, Harry Knudsen, and 4 senior executives without pay. They reported the fraud to the Consumer Product Safety Commission. Underwriters Laboratories delisted nearly 400 FPE circuit breaker labels. The company's own SEC filings stated that UL listings on their breakers had been obtained through deceptive and improper practices. A New Jersey judge confirmed it in 2002, ruling that FPE violated the Consumer Fraud Act by knowingly distributing breakers that had never been properly tested to meet UL standards. The class action settlement, resolved in 2008, gave original New Jersey homeowners just $500 per panel. The actual cost to replace one runs $1,500 to $4,000, and that settlement covered only one state, which brings us to the question that should have been answered 40 years ago. Why was there never a recall? The Consumer Product Safety Commission opened its investigation in June of 1980 and hired engineer Jesse Ehrenstein to test the breakers. He tested 122 2-pole Stab-Lok breakers and found that 51% of individual poles failed to trip at standard overload conditions. After endurance testing, failure rates climbed to 65%. 1 in 10 breakers jammed completely, contacts fused shut, permanently unable to trip at any current level. The CPSC's own lab independently confirmed the results, finding 85% of double pole and 39% of single pole breakers failed one or more UL test criteria. The evidence was overwhelming. The breakers were defective, and the company had lied about it for over a decade. But in March of 1983, the CPSC closed the investigation. No recall, no safety ruling. The reason was money. The CPSC's total annual budget was $34 million. Staff estimated a full public assessment would cost several million, a significant portion of the entire agency's funding. They had also just lost an 8-year lawsuit against Kaiser Aluminum over aluminum wiring, where the court ruled that products installed by builders might not even fall under CPSC jurisdiction. FPE could make the same argument, and the company behind FPE was not some small manufacturer. It was Exxon Corporation, with more legal firepower than the commission would see in a lifetime. So the investigation was closed. The panel stayed in the walls, and most Americans never heard about it. It took until 2011 for the CPSC to clarify that they had never declared the panels safe. They simply could not afford to declare them dangerous. Jesse Ehrenstein did not stop. He was an engineer with a doctorate and a professional engineering license, and he had made this his life's work. He spent the next 4 decades testing over 3,000 FPE breakers pulled from homes across the country. Every single panel he tested contained defective breakers. In a 2012 peer-reviewed paper published in IEEE Transactions, he and a statistician built a model estimating these panels caused thousands of fires and dozens of deaths every year. Over 4 decades, his extrapolation reached roughly 100,000 fires, over 500 deaths, and more than $1 billion in cumulative property damage. And he identified something chilling about why homeowners never notice the danger. Most breakers in a home are never called upon to trip in their entire service life. The homeowner's perception is that the panel works fine because nothing has gone wrong, but Ehrenstein pointed out that the same could be said if there were no breakers installed at all. A panel that never trips is not proof of safety. It is simply a panel that has never been tested by a real emergency. In 2019, Congressman Paul Tonko of New York wrote to the CPSC demanding they reopen the case. He cited the staggering toll. Over 4 decades, the numbers speak for themselves, a 6-figure count of preventable fires that may have been caused by these defective breakers. No recall followed. No criminal charges were ever filed against any FPE executive for the certification fraud. So here is what you need to do. Go look at your electrical panel right now. Open that gray metal box in your basement, garage, or utility closet. If you see the words Federal Pacific Electric, the letters FPE, or the term Stab-Lok anywhere on the label or the breakers, you have one. They are most common in homes built between the 1950s and 1980s. Do not ignore it. Every major home inspection organization recommends immediate replacement. Many insurers now refuse to cover homes with these panels entirely. The investigation that might have prevented all of this would have cost the government a fraction of the damage it allowed. They chose not to spend it. That panel is still in the wall. If this investigation was valuable to you, share it with someone who owns an older home. Hit subscribe so you do not miss the next one. And if you have a Federal Pacific panel in your house, do not wait for a recall that is never coming. Get it replaced.